Hello everyone. Today we will be learning about the reactions of metals, and this is part of the metals topic. We'll be first starting with chemical reactions, and the first chemical reaction we'll be looking at is a synthesis reaction. As the word synthesis means, it is when a reaction where two or more elements are going to be combined to produce a new compound. Now let's take an example here. This is just a demonstration. So we have A joining with B to form AB. And now this is what simply happens in a chemical reaction. That's a synthesis reaction. So we'll take a real example now. We have iron reacting with sulfur to form iron sulfide. Now this is a chemical reaction and it's written using chemical formulas. So to work out the formulas for iron sulfur, you refer to your periodic table. If you refer to your periodic table, under iron you would find Fe, under sulfur you'll find S, and when you combine these two you would form iron sulfide. Now I would write the word equation here so you would understand it more. We have iron reacting with sulfur. So this is the reaction that's happening in a word equation, and they're forming iron sulfide. So when sulfur is in a compound, it forms sulfide. So the sulfur, the UR in sulfur is changed to IDE. So you replace UR with IDE, as you can see. So iron plus sulfur gives you iron sulfide, and that's a synthesis reaction. Now we'll be looking at a decomposition reaction. A decomposition reaction is a reaction where a compound is split into smaller substances. So it is the opposite of a synthesis reaction. Now let's take an example. We have AB, a compound, reacting to form A and B. So it's separating. Now to take an example of a chemical reaction that's a decomposition reaction, we have mercury oxide here. Now mercury oxide has a mercury molecule, it's a mercury atom, and an oxygen atom together. Now they react in the presence of heat, and that's why next to, on top of the arrow, you write heat, because heat acts as a catalyst. Now what a catalyst is that it forms it's needed, so heat is needed for the mercury oxide to react. In other words, it's a trigger, or it provokes the reaction. So it reacts to give us mercury, a metal, and we get oxygen as a gas. So we have mercury oxide giving us mercury and oxygen. Now note that you have to write your states down. We know that mercury oxide is a solid. It's usually given if you don't know it. So in this case, it might be given. But then mercury as being a liquid is something you should know by this stage. So mercury is the only metal, or one of the few metals that exists in its liquid state at room temperature. And oxygen here, oxygen gas, also exists as a gaseous, in its gaseous state as a gas. Now this is our chemical reaction. Now you would also notice that we have coefficients here. In other words, numbers in front of the symbols. These are what you call balanced equations. And to balance our equations, you may have to put these coefficients. So what this 2 here means is that there's going to be 2 molecules of mercury oxide reacting to form 2 molecules of mercury and 1 molecule of oxygen gas. So we'll be looking at combustion reactions now. What a combustion reaction is where a compound or an element reacts with oxygen to produce an oxide and also heat. Now let's look at this more carefully. We have one equation like this. This is methane. You'll be learning about this in a greater depth, especially in year 12, but also later in your course. So we have methane here reacting with oxygen. So O2 is oxygen gas, and they react to form carbon dioxide. As you can see, CO2 is carbon dioxide, and water, which is H2O. Now, methane is what you call a hydrocarbon because it only has hydrogens and carbons, therefore it's called a hydrocarbon. When hydrocarbons undergo combustion, the products are always carbon dioxide and water. That's something you should remember, and you'll be learning this in a greater depth in the years to come. So this is methane reacting with oxygen, but this is a hydrocarbon, so this is a different case. We have another case, and that is the most common, and this is when combustion is undergone on a metal. So metal is undergoing combustion here. So the metal here is magnesium. It's reacting with oxygen. When it reacts with oxygen, it forms magnesium oxide. Now, you may have done this in school where you used magnesium strips and you would heat it up, and then the magnesium strip would turn into a white powder. Now, this white powder is magnesium oxide because the magnesium strip would react with the oxygen in the air to form magnesium oxide. So we call this a combustion reaction, and this also a combustion reaction because it's reacting with oxygen. So you can see how that works. Now let's move on. We're going into oxidation and reduction reactions. Now these also will be done in a much greater depth in year 12, but we'll be looking at it briefly in year 11 chemistry. So a reaction where electron transfer occurs between reactions to form products. Now look at this animation here. We have magnesium. Magnesium has 2 electrons, and those 2 electrons go to the copper, and there's a transfer of electrons. So wherever there's a transfer of electrons, there's an oxidation and a reduction reaction happening. When those two happen simultaneously, we call it a redox reaction. So for example, we'll take magnesium and oxygen, the example we talked to before. So magnesium, the metal, is reacting with oxygen, the gas. And when they react, they form magnesium oxide. Now look at this. Magnesium is a metal and it has 2 electrons that it can donate. When it donates these 2 electrons to our oxygen here, it forms the magnesium ion that's in this ionic compound. As you can see, magnesium oxide is an ionic compound because it has magnesium ions and oxygen ions. So to make the magnesium ion in the ionic compound, the magnesium here would lose 2 electrons, and then the oxygen, to make this ion here, would have to gain 2 electrons. So the 2 electrons lost by magnesium over here is gained by oxygen, and that's an electron transfer. Now let's look at another electron transfer, and this is the model here. So where magnesium is reacting with copper ions. When it reacts with copper ions have 2 valent vacancies for electrons. So these 2 vacancies are filled with the 2 electrons coming from the magnesium. When it comes from the magnesium turns into an ion. So at this stage, magnesium is a ion while copper is a metal. But then at this stage, it's an ion. When copper doesn't have any, it's an ion. So as you can see, magnesium plus copper ions would give you magnesium ions plus copper metal. Combustion reactions are a type of oxidation and reduction reactions. Remember, we just learned about combustion reactions where magnesium plus oxygen would give you magnesium oxide. Well, it is also an oxidation reactions. So they come under oxidation and reduction reactions. Now let's move on to neutralization reactions. Now this type of reactions were covered in year 10, but now we're going to be looking at in a greater depth. A reaction where an acid and a base would react to produce a salt and water. So what happens is basically it is a reaction between an acid and a base. Now let's take an example here. We have sodium hydroxide reacting with hydrochloric acid. Now you know that sodium hydroxide is a base. So we have a base reacting with an acid, because hydrochloric acid is an acid, and they are forming NaCl. NaCl is sodium chloride. So sodium chloride along with water, which is H2O. So sodium chloride is a salt and water is also a product, as you can see. So base plus acid would give you a salt and water. Now this is the equation. We also have another example where we have ammonia reacting with hydrochloric acid. Now ammonia is a base and hydrochloric acid is the acid. When those two react, they only form ammonium chloride. With chemistry, there are rules like this one where acids and bases react to produce salt and water, but it doesn't apply for all acid-base reactions. For example, this one. This is an exception, and it's an exception that you should know. So it doesn't form water, but the hydrogen and the hydrochloric acid and ammonia would join together to form ammonium chloride. So you can see how you would write the chemical equation. Now let's go to balancing chemical equations. Now chemical equations are something quite new to year 11, but we'll be learning about how you can do it. So by year 12 you'll be very fluent with chemical equations. First of all, it is best to write your general word equation, and this is something like acid plus base would give you salt and water. So we'll start off with that. We'll write that acid plus base gives us salt plus water. So this is our general word equation. So first of all, when you see a chemical reaction, you should identify it as a neutralization reaction or a combustion reaction or an oxidation-reduction reaction. So first of all, you would identify the reaction and write the general word equation. What you then would do is specify the word equation. In other words, you look at what are the chemicals that are reacting and what products are going to be formed. So in this case, we're going to take an example. We'll take hydrochloric acid as our acid. So hydrochloric acid, which will be reacting with a base. We'll take sodium hydroxide. When those two react, they form a salt. And how to work this salt out? You have sodium here, going to react with the chlorine. So it'll form sodium chloride. Sodium chloride. And also water, because water is a product. So this is our specified or specific word equation. It's in words and it's an equation. Then what you would do is write your chemical word equation. In other words, you would figure out the formulas or the chemical formulas for each of these and write it out. So hydrochloric acid is HCl. And then our sodium hydroxide, as we all know, is NaOH. Then this would produce sodium chloride. Sodium chloride is NaCl. And water is H2O. Now, how to figure these out? HCl. Go to your periodic table and you would find H is in group 1 and Cl is in group 7, which means that each of these have a valency of +1 and -1. Remember cross multiplying or crossing the two together. So we would cross these around and you would get H1 Cl1. Remember, you don't write your ones, so you would cross out the 1 from each and you would get HCl, and that's how you would go about writing a chemical formula for your compound. We'll take another example. We have NaOH. NaOH has a sodium ion and an OH ion. Now the sodium, if you go to your periodic table, you can find it under group 1, which means it has a valency of +1. OH is one of those anions that you should remember the valency of. There are a few and you should remember them, but as we come across, we'll just memorize them. So for now, just know that hydroxide, the hydroxide ion, which is OH minus, has a valency of -1. So it'll be -1 like that. Now you would cross them together and you would get Na1, OH1. Again, you don't write your ones in because they're just one. You would rub them out and you would have NaOH, as you can see here. And you would apply a very similar method to your sodium chloride, because sodium is in group 1 and chlorine is in group 7. So you would cross them out to get Na1Cl1, which is eventually going to be NaCl. Now water is simply H2O, as we all know, and that's something that's universally known. So let's go to the next step. Now since we have a chemical equation here, the next step is to balance our equation, because balancing is very important. Now to balance the equation, what you do is you would consider the number of atoms on this side and consider the number of atoms on this side. We'll first start off with our H, which is a hydrogen. We have one H on this molecule and one H on this molecule, giving us two hydrogen atoms. And on this side, we have two hydrogen atoms from our water. So we have a total of two hydrogen atoms on each side, so it's all balanced. Moving to our chlorine, or the chloride ion, we have one chlorine atom here and we have one chlorine atom here, so our chlorines are balanced. Let's move to our sodium, Na. So sodium, one of them here and one over here, so that's 1, 1, making them balanced. Now let's move to our oxygen. We have one oxygen on this side of the equation and we have one oxygen on this side of the equation, making the oxygens balanced. So this is one of those equations that are already balanced for us, so we don't need to balance it further. However, it is very important that you check it before. So before you move further, you have to check whether it's balanced, and that is a very important step. So I would call this a very important step. The next step is to write your states. So to write our states, that's our physical states, we have to know which state each of these chemicals are going to be in. So first we have hydrochloric acid. Now acids and bases are usually in their aqueous form. In other words, they're going to be ions in solution. So we are going to write a little AQ next to aqueous, or hydrochloric acid, because AQ stands for aqueous. And then we have sodium hydroxide, again a base. So bases are usually again in aqueous form, so you would say AQ. Then we have sodium chloride. Now you would know this by the end of the year, that sodium chloride is going to be aqueous, because you'll be learning the solubility rules. But before that, just remember that sodium chloride, which is a salt, and usually most salts are in aqueous solution, so AQ. And then we have water. We know that water at room temperature is going to be liquid, so you would write a little L next to it. So that's how you would show the physical states, and that's how you would balance a chemical equation. Now let's move on to an example to write an equation for the reaction of hydrochloric acid on solid sodium carbonate. Now this is a different reaction to what we just did. It is using hydrochloric acid with a carbonate. Remember that acids with carbonates produce carbon dioxide. So that's why with your general word equation, you would write down what are the products and also what are the reactants. We have an acid reacting with a carbonate to produce a salt, water and carbon dioxide. Now you would write the chemicals that you're going to be using. So as our acid, we'll be using hydrochloric acid. As our carbonate, we'll be using sodium carbonate. As our salt, we'll be using sodium chloride. As our water, we'll be using water. And carbon dioxide is going to be the gas produced. So that's just writing in what we got here, or the chemicals that are used and the chemicals that are going to be produced in our reaction. Now you would turn this word equation into a chemical equation. So to write your chemical formulas, we know that hydrochloric acid is HCl from before. Then sodium carbonate. Now carbonate is one of those anions I was talking about before. So first you would write your sodium and your carbonate. Carbonate is CO3. Now sodium has a valency of +1 because it's in group 1. And carbonate is one of those ions again that you should remember. So the valency of the carbonate anion is -2. And that is something you should remember and memorize. So write it down somewhere so you remember, along with your hydroxide ion, which has a valency of -1. So now if you cross them along, as you would work out the chemical formulas, so you would have Na2 and CO3 with a 1. So because you don't have to write your 1, it's going to be Na2CO3 as you got here. Then we move on to sodium chloride. Remember, sodium chloride is NaCl because sodium is in group 1 and Cl is in group 7, so they both have a valency of 1. We have water and carbon dioxide being produced. So that's our chemical equation. Now that doesn't stop there. What do we have to do next is to balance our equation. So to balance our equation, we have to see how many of each of the atoms, whether it's balanced. So we'll start off with our carbons first. How many carbons do we have on this side? We have 1 carbon from our sodium carbonate, and here we have 1 carbon from our carbon dioxide. So the carbons are balanced. Let's move on to hydrogen now. We have 1 hydrogen on this side and we have 2 hydrogens on this side. So our hydrogens are not balanced. So to balance our hydrogens, what we do is we put a 2 in front of the HCl. So we have 2 hydrogens now. Do you see that? So it's all balanced, the hydrogens. Now let's move on to our chlorine ions. We have 2 chlorine ions here because of the 2 we put in front of the HCl. And then we have 1 chlorine ion here. So we have to balance our chlorine ions. In order to do that, we put a 2 in front of our NaCl. Now let's balance the sodium ions. We have 2 sodium ions here. And we have 2 sodium ions on this side as well because Na is times by 2 due to the coefficient of 2 in front of NaCl. Now let's balance our oxygens. We have 3 oxygens on this side and we have 1, 2 over on this side along with this giving us 3. So we have our oxygens balanced. Now that is a balanced equation. As you can see, it's written 2HCl with 1 molecule of sodium carbonate giving us 2 molecules of sodium chloride, 1 molecule of water and 1 molecule of carbon dioxide gas. Now what you would do is you would have to write your states down. That's our last step, to write the states. Now remember, the state of an acid is always aqueous. Sodium carbonate, it's already given to us saying solid sodium carbonate, which means it's going to be a solid. NaCl is aqueous, water is liquid, and carbon dioxide is a gas, so it'll be a G. So your chemical equation would look like this. You would have 2 hydrochloric acid molecules, which are being in aqueous form, reacting with the sodium carbonate to form this. So you can see the G representing gas. Now let's move on to a question. These are very common in the HSC. Even though you're still in year 11, you would find that these are the questions that are going to be in the HSC, and they're not just worth 2 marks or 1 mark. They're actually worth 3 marks, and they're easy 3 marks that you can get, and they're calculations. So you know you're going to be right or whether you're going to be wrong. So it's easy to get these marks. Now let's go through this question. 6 grams of magnesium metal is burnt in air and converted to magnesium oxide. So in this question, we are supposed to find the mass in grams of the magnesium oxide. Now they have given you the atomic mass of magnesium as 24 and oxygen as 16. Where they have derived these masses from is, go to your periodic table, and if you go to magnesium, which is Mg, you would see 24 written there. Now this is the atomic mass. In other words, how many protons and neutrons there are in the atom. And you would find the same thing with oxygen. It will say 16 on the oxygen box. Now let's see what this first step is. The first step is to write a balanced equation for the reaction. So we have to go back to the reaction and see what's happening. It's a burning reaction, which means it's a combustion reaction. So magnesium is going to burn along with oxygen to form magnesium oxide. And then we have to balance our equation. Now this is balanced for you, but if it wasn't balanced for you, you would have to go, the magnesiums are balanced, and then we have two oxygens here, but we have only one oxygen here. So you put a 2 in front of the MgO, but then our magnesiums are not going to be balanced, so you would put a 2 in front of the Mg. So that's a balanced equation. Now after writing a balanced equation, you would go about trying to get all your data and all arranged so it's easy for you to work on. Now it is it was very important to get your relevant data. Now in this case, we're given that the magnesium metal is 6 grams, so 6 grams of our magnesium metal is used. And then how many grams of magnesium oxide, which means we're going to be comparing the two. So we'll be using our magnesium mass to find out the mass of the magnesium oxide being produced. So you would write your answer like this, so it's easy to compare. Now we have 2 molecules of each, because from our balanced equation we can see 2 molecules of magnesium are used to form 2 molecules of magnesium oxide. So you would write the 2's. Now what happens is, now you have to times the masses. So we have 2 atoms of magnesium used. That means 2 times 24 are being used. The next one is 2 times 16 plus 24. Because magnesium oxide has a magnesium atom and an oxygen atom, we have to add them together. So magnesium is 25, oxygen is 16, giving us a total of 40. So 40 times 2. Then you would just simplify it. 2 times 24 gives you 48. 2 times 40 gives you 80. And you would compare your results like this. Now go back to your question. You're given that 6 grams of magnesium metal is used. So you would write 6 grams under your magnesium column. Now you don't know the value of the magnesium oxide, and that's what you're after. So at this stage, you would try to isolate your X. And to do that, you would use a ratio and solve it. So we would say that 48 over 6 is going to give us 80 over X. And you would cross multiply this and try to isolate our X. When you isolate X to one side, if you solve it further, you would get 10 grams. And this is a simple calculation. Now you would never leave your answer at this stage, because this is not correct. It's only saying that X is 10 grams. But what is X? We haven't given a value for X yet, or a name. So for your last step, you would write a statement. And in this statement, you would say 6 grams of magnesium produced 10 grams of magnesium oxide. So in this section, what we covered was how we work out our magnesium mass to mass statement, as well as how we looked at our chemical equations, and we studied a few reactions such as the combustion reaction and the neutralization reaction. Why don't we try some questions? We have question 1 here. Which of the following is a combustion reaction? Now we have 4 options here. We'll consider each. So is it option A? Option A is not a combustion reaction, it's a decomposition reaction, as you can see. So option A is not the answer. Option B, which is a carbonate decomposing again. So because it's not reacting with another species, so it's not option B. D is a ionization reaction where hydrogen ion and the hydroxide ion are reacting together to form water. So option D is not the answer. And we're moving to option C, where we have sodium reacting with oxygen. Now oxygen, when it's reacting with oxygen, that's when combustion is happening. So when sodium is reacting with oxygen to form sodium oxide, now that's a combustion reaction. So option C is the answer. Now moving to question 2, which of the following is an oxidation and reduction reaction? So what are the things you have to look for an oxidation and a reduction reaction? There's supposed to be an electron transfer. Now in our first reaction, there can't be an electron transfer because it is a decomposition reaction. So A is not the correct answer. Moving to option B, we have again a decomposition reaction happening. So option B is not the answer because decomposition cannot provide oxidation reduction reactions. Option D is an acid-base reaction. You can see HCl is an acid and NaOH is a base. So when they react, it's a neutralization reaction. So option D is not the answer, giving us option C, which is iron reacting with oxygen to form iron oxide. Now iron 3 oxide here is formed by iron and oxygen. So iron would be undergoing oxidation while oxygen would be undergoing reduction to form iron oxide, as you can see. So option C is the answer. Now moving on to question 3, which of the following equation is correctly balanced? So we'll be considering each option one by one. First of all, we have option A, which is the hydrogen atom and the oxygen atoms are not balanced. You can see the hydrogen, there are 2 here and 4 over here. So they're not balanced. And the oxygen, we have 2 here and we have 3 on this side. So they're not balanced, making option A incorrect. Moving on to option B. So option B, we have the hydrogen atoms not being balanced. We have 8 hydrogen atoms but only 4 on this side. So the hydrogens are not balanced. Moving to option D now. Option D has the carbon and the oxygen atoms not balanced because we have only 1 carbon but we have 2 carbon atoms on this side. So clearly the carbons aren't balanced. What about the oxygen atoms? We have 4 oxygens here but we have 6 oxygens on this side. So D is not the correct answer. So considering option C, option C has all of the atoms balanced. We have 1 carbon, 1 carbon, 4 hydrogens, and we have 4 hydrogens when you times it by 2. We have 4 oxygens and we have 2 oxygens from here and 2 oxygens from here, giving us a total of 4 oxygens. So both sides it's balanced, making C the correct answer. Now moving to question 4, it says write a balanced equation for sodium reacting with oxygen to produce sodium oxide. Now in this case, I would underline these 2 words, sodium and oxygen, because those are our reactants and our product is going to be sodium oxide. Now this is a synthesis reaction but is undergoing a combustion reaction as well. So identify the reactants and the products as we have just done and place the reactants at the left hand side and the products at the right hand side of the arrow. So it's just simply writing it there. But then you would have to work out the chemical equation for each. So balance the atoms. Now this, you can't leave it like that. You have to balance your reaction, the atoms on each side of the equation, and intercept whether it is, inspect whether it is balanced. So here we have 4 sodium molecules reacting with 1 oxygen molecule to give you 2 sodium oxide molecules, and this is a balanced equation. Because it's asking for a balanced equation, it's very important to get your full marks. You should balance your equation, and I would recommend you to write your states if you know the states, but if you're unsure about the states, please leave it out. Now add states at each reactants and products using a bracket. So here we have states written: solid, a gas, and a solid. So you should be able to write the states as well, because it's asking for a complete equation. Now moving to question 5. Question 5 says, write a balanced equation for the combustion of methanol to produce carbon dioxide and water. Now here we have methanol reacting with oxygen to form carbon dioxide and water. Remember, I told you methanol is also a hydrocarbon, which means that all its products under combustion is going to be carbon dioxide and water. So you would first balance the number of hydrogens on each side. You would always start with your hydrogens. So you have 4 hydrogens on this side, and you would have 4 hydrogens on this side. So that's all balanced. 1 carbon, 1 carbon. The oxygens, there are 3 here and 3 here. So this is a balanced equation. So you would have to add a 2 in front of the H2O in order to balance your equation. Now balance the number of oxygen atoms so that the 4 oxygen atoms are on each side. So you would have 4 oxygen atoms on each side. Now that's the thing, when you're going to balance it, you would have a fraction coming along, because you only want 1.5 of molecule of oxygen. In other words, you only want 3 oxygen atoms, but oxygen occurs in a molecule of 2. That means you would need 1.5, so you would write 3 over 2. Now this looks very tedious at the moment, so to make it more simple, you would times each molecule by 2. If you do that, you would add a 2 here. When you times this by 2, the 2's would cancel out, giving you 3 on this one, 2 here, and when you times 2 by 2, you would get 4. So eventually your equation would look like this. You would have 2 methanol reacting with 3 oxygen molecules, giving you 2 carbon dioxide molecules and 4 water molecules, as you can see. Add your states. Of course you would have to add your states. Methanol is a liquid, which is a fuel, and then we have oxygen, which is a gas, carbon dioxide a gas, and water as gas, because this is a combustion reaction. In other words, there's going to be high amounts of heat produced, giving water as a gas instead of a liquid. So that brings us to the end of the lesson today. We covered combustion reactions, neutralization reactions, synthesis reactions, decomposition reactions, and many chemical reactions. We also learned how to write chemical formulas and also a chemical reaction. So we learn how to balance our equation and also to add your states.